Hello, everyone. Thank you for attending. Just one quick housekeeping. We still have our past Summit 2018 registration offer going till the 22nd. After the 22nd, we'll be starting a new promotion code for $100 off the registration. I'll be sending out that code once we receive it. Today we have James Miller speaking about populating a data warehouse with SSIS and BI markup language. James has been in the IT industry for over 30 years. He has roles as a data architect, DBA, IT director, and a senior consultant. Without wasting any time, James, I will give you presenter.
Okay. All right, just need to know how to share my screen. There we go. Okay, hopefully everybody can see my screen.
Yep, we see your PowerPoint slide right now.
Okay. All right, well, again, my name is Jim Miller. I'm the president of BI Tracks Consulting. This presentation is on using Biml to populate a data warehouse. I've been working with Biml and a variety of Biml products for a number of years and have determined that there's got to be an easier way to use Biml, and that's what this presentation is all about. You can use these techniques to populate any, use it for any data flow, any ELT, ETL, but we do have some patterns and code generators that are very specific to building data warehouses that come in handy. Let me start by saying everything that you will see today is free. This would be Biml Snap Online. This would be Biml Express. And you could even use it with SQL Server Express. So there's nothing that you'll see today that costs anything. All the downloads are at bimlsnap.com, and I will show that to you shortly. Okay, so why use Biml to build SSIS packages? Well, the key reason is code reuse. Biml is simply XML. XML is code. Code can be reused. That's a fundamental piece that was missing from the Microsoft BI stack. And it was recognized from Microsoft as a potential issue for people who wanted to use reuse for acceleration and all the other benefits that you get with reusing code. They started a project, it was called Project Vulcan. This was to address this issue, and this is where Biml came out of. About halfway through the project, Microsoft took a little bit different tact. The Power BI products were starting to emerge, so they decided to halt this particular project. And their senior architect, a man by the name of Scott Curry, decided to take this to market. And long story short, he did that. He's created the ecosystem. And in fact, Microsoft is his best customer for using his suite of Biml products. What Biml also gives you is a way to define resources outside of SSIS. So you want to create connections and parameters, and you would like to have consistency from project to project, but that's a little bit difficult to do just using Visual Studio. So it's another example where Biml allows you to define that, and you'll see this in a minute, outside of SSIS, where you have reusable and standardized connections, parameters, packages, etc. Also, using the packages, or the patterns, all of your packages come out very consistent. So if you need to hand off a project to another person because these patterns are behind each package, there is great standardization with the finished product, which is very helpful when you have multiple developers and you're building SSIS projects. Finally, accelerated change management. So if you ever needed to make the same change to 5, 10, 50, 100 or more packages, you know how painful that can be to open up each one, point and click, drag and drop, save, go to the next one, and try not to fat finger something or not quite make the change. So these are all the reasons you would want to use Biml. Here's how Biml Snap aligns with the Verigent's product ecosystem. So we do use Biml Express. We have our metadata editor, which is actually just another SQL Server database. All of our code is in SQL. And we, again, use Biml Express for the build. And the output finally would be 2012, 2014, 2016 SSIS packages. We don't do SSIS, and we don't really manage your schemas, although we do have a metadata solution that this works in conjunction with. So that's how it aligns with Verigent's. Very simple workflow. Moving from left to right, you'll see the Biml Snap front end. This is a web-based front end. It's free to use. You can go to bimlsnap.com, go to the online page, and there's a try it. It'll take you directly to this particular form. After you build your project, so you define connection parameters packages, just like in SSIS or SQL Server Data Tools. You copy the Biml file over into SQL Server Data Tools, and from there you generate all your packages. So it's literally fully developed from an empty solution to as many packages as you define. And then, of course, by running the package, you would then populate a data warehouse or do whatever ELT work that you need to do. Okay, so I mentioned Biml Snap Online. So you just go to bimlsnap.com, and from there you'll see this particular link. This gets you to the actual application. So that's one component is just the website. It's free. It will continue to be free. Also, you're going to want Biml Express from Verigent. This is an add-in that goes into Visual Studio or SQL Server Data Tools. It is also available at no charge. We do have a Runtime Framework. You'll find out more about that later. It's optional, but it's very handy for standard features that you would like for each of your packages to have. We also have a metadata solution. And really the power in using Biml is leveraged from the metadata of the databases or data warehouses, the staging tables, etc., that you would like to populate. So it's a much better user experience to use SnapMart. It's a free solution. It collects your metadata, your table names, your column types, is it nullable, etc. And then you can upload it optionally to the website, to Biml Snap, and then the drop downs and the code generators understand your metadata, and it provides a much better user experience. Okay, so I'm going to stop at this point and show you what it looks like for the downloads that you'll get. The downloads from bimlsnap.com, you just go to the online page and choose downloads. And you can see there are actually 4 downloads that you'll get. You get the framework database, you get the metadata database, you get the metadata refresh project. This is actually just an SSIS project that's been developed using Biml Snap to extract the metadata from whatever server that you designate. And then a metadata front end, which enables you to extend this metadata just a little bit. For example, for the merge statement, to designate this is a type 1 attribute or type 2 historical attribute. So just by going to the download page, you will get these 4 files. If you want to use the metadata, and by the way, you can use it just as a standalone application. Forget Biml Snap entirely. You just want to use it as a data mart for your metadata. There's no reason you can't do that. So you get the database, and this is simply the DDL. Create the database called SnapMart. You can choose a different name, but I recommend using that, of course. And then just run this script, and it'll create all your tables and your procedures. And you will get this particular database. And just to quickly run through the table so you can kind of see how the data mart works. The SSIS will go through and it'll extract from whatever server you're pointing to all the databases, columns, and tables. Now tables and these 3 are actually what you would upload to Biml Snap. And so for example, if you look at the columns, the column information is all populated just using the information schema metadata view within SQL Server. But notice that we add this particular column, which designates the merge type. So everything else that you have here is just straight metadata from your server, your tables, your columns. But at the column level, we do supplement that with the merge type. Well, how do you supplement it? Well, in order to supplement it, we have the front end. So this is, again, this is a free download. And you just give the name of your server and database. And then once you run it the first time, it will collect all of the databases that are on your server. If you choose to extract the metadata, then what you would do is just indicate with a yes, you want the metadata from, for example, the database that's EDW, or in this case, the metadata that is host operations. In addition, if you're going to use it as a staging database, and a staging database is best thought of as the step just before your dimension. And the reason that's important is in order to generate the merge statement, we need to know the extended metadata, or type 1, type 2, etc., for any tables. So you would want to say, if this is a staging database, that you would want to use it as a staging database. So if we now go over to the column types, and notice this is only for staging databases, we would say we want the EDW database, the staging schema. And so, for example, we'll look at the metadata that we have specified for the drive. Well, these would be any number of drives that are on a system, drive C, drive D. So host role, and think of that as just host, it's simply an alias, along with the name of the drive, CD, etc., comprise what is known as a composite business key. So this is a natural key for any drive that's on one of your host servers. Then the rest of the merge types, in this case, are set to type 1, which means we're not concerned about the historical view of this particular dimension. Well, let's look at host. Well, what makes host unique is the host role, or think of it just as the server name. In this case, we decided if it changes the domain, we're going to make that a type 2, meaning we'd like to know historically of that type of change. Or, for example, if somebody added a password, power-on password, we'd like to know that as well from a historical perspective. And total amount of memory, if that changes over time, we'd like to have that historical. So you can see how you would use these types, or you're extending the metadata just a little bit in order for the code generator that will build you your merge statement to be able to work. Finally, you'll see there's an export option. And from this front end, after you build your metadata, you export it to a file, and this would be a JSON file. I'll just put it on the desktop. And so it exported these 3 tables that I had mentioned. And so that should now be on your desktop. So we'll just take a peek over there. And here's the file that we just exported. If we go back to this database, again, it is these 3 tables, so you can see exactly what it's sending. The last 2 tables are in fact true dimensions, which would give you the historical perspective. So this, like any dimension you might build, has a couple of extra columns. Is the row current, the effective date, the expiration date, when it was inserted, etc. So we don't need to export these, but we do want to export these 3. So the drop downs, once you populate them in Biml Snap, would be able to provide that user experience, and the code generators would work as well. So we'll go back to Biml Snap login. And once you have your account, there's a button that's called Upload Metadata. So you choose that, and then go to the file. In this case, it's on the desktop. Choose it, open it, and that's how you can upload your metadata, so the front end then has all your metadata. Okay. Once your metadata is loaded, then the workflow, instead of this model we saw just a minute ago, the workflow changes to this, where you extract, again, just using a provided SSIS project that's part of the downloads, populating your Snap Mart metadata, and you just saw that database. You get the DDLs for that. You upload it to the website. It now understands your schema, your tables, your columns. Now you can generate your Biml using drop-downs that understand your data, as well as critical information such as type 1, type 2 for code generators. And then you would run that, populate your data warehouse, and so that would be the overall workflow. Okay, and so this is where we talked about the metadata management, type 1, type 2. You do get the front-end client for free. It just extends your information schema views. And you can run this SSIS project to actually refresh your metadata. That was built using Biml Snap. Okay. By the way, these slides will be available afterwards, and there's some helpful steps on getting started. But what I just ran through in terms of getting started are outlined in this particular slide. Okay, you also get a Runtime Framework. When you build your packages using Biml Snap, you can choose a total of 3 frameworks or templates. One is a no framework template, so it's just very bare bones, doesn't do anything. There's a standard template that gives you all kinds of features, such as project restartability, package row counts, runtimes, email alerts, error logging. The restartability is very nice, because if you have a long-running project, let's say it runs for 8 hours, and maybe overnight, you're halfway through, it breaks. Well, once you restart it, it knows exactly where to pick up by virtue of the tracking of the progress of the previous run. So that is a really handy feature. Plus row counts, especially in data warehousing, but this is also a very good metric. It's not really, it's helpful to know when it started, when it stopped, and that it said it was successful. But if you expected it to move 1 million rows and it moved 10 rows, then that would be a red flag. And so it's always handy to look at that in terms of runtime metrics, as well as trending. If you see that you're moving 1,000 rows and suddenly 1,000,000 and then 100 million, then that would also be a concern with that hockey stick on row counts. Okay, this kind of gets into, well, what really is the difference between using Biml and Biml script versus just pure Biml. Biml, of course, is the most powerful if you can add Biml script to it, meaning that you can have code which is reusable based on metadata. So if you want to, for example, do the very same thing to 100 tables, then you're able to do that using Biml script and these code nuggets. What we do, instead of using these code nuggets embedded inside of the Biml, is we just generate this directly from the database. So probably a lot of people are interested in, well, really, how does that work? And so this should answer a few questions. So let me get to, let's open up. All right, so if you look at, for example, the connection table, and this is what's going on behind the scenes in the back end, you can see that we have a total of 6 connections that are defined. Well, if I wanted to create the Biml equivalent for these 6 connections, then what I would do is run a select for XML. Running this select, I can now get the Biml to define these connections. And it's not much of a stretch beyond a simple select, but it does in fact create Biml that can be fed into Visual Studio using a Biml Express to create connections. And this is a pretty simple example. So let's look at one a little bit more complicated. In this case, we're going to look at connections and we're going to look at parameters. So now there's two tables that we are interested in. The first table gives us those same 6 connections. The next one gives us parameters that would be used to configure these connections. What Biml Snap will do automatically is when you create a connection, so for example, the EDW, this would be for your data warehouse. When you create that connection, it automatically creates 3 parameters to go along with that. So you'll see EDW database, provider, and server. The reason for this, of course, is when you go to promote your code or your packages, you would like to parameterize the actual environment so you don't need to go into each package that you created and set it to connect to a different server or a different database or even a different provider. So these are proactively created for you, and then the script to generate these parameters is also scripted when you choose to build. So if we wanted to create the Biml that would not only define our connections, but give us expressions for the parameters, then we would want to run this particular query. And now you can see it's a little bit deeper example of the Biml. Now, we don't have the projects yet, we don't have the packages yet, but conceptually you can see what's happening is it's leveraging just those table entries, because everything from beginning to end is table driven. It's leveraging that to not only define your connection, but also to define the expression that is used at runtime in order to, for example, create your connect string based on the parameters that are automatically created for you by virtue of creating a connection for EDW. And you can see the same thing for host ops, or snap build, snap Mart, SSIS data. This is the Runtime Framework database. So that's really the magic behind how Biml Snap works, is by just using everything in the database, stored procedures and functions that use the select for XML, and it outputs obviously Biml, and then the trick is to move it into your project, build, and then run, and we'll go through that in just a minute. Okay, and as I had mentioned, we use stored procedures tables. To generate pure Biml. We have a repository of reusable ETL patterns, and you'll see this in just a minute, but you choose your pattern, and essentially, because we do really ELT, not so much ETL, although you can do some of that. What ELT basically says is we're going to extract from one place, load it to another, and then we're going to transform. So the two critical pieces are your pipeline, extract and load, and then transform, which are execute SQL statements. Okay, so let's take a look at how this would work. This would show you how to get started with a Biml Snap Online. So let's just go ahead and jump over to Biml Snap Online. All right, here's a project that is really a very simple set of data flows that are going to move a total of 5 tables from an operational database over to the EDW database in the source schema. So let's look at behind the scenes what these databases look like. So host ops, and what this database will do is collect information about your servers, performance counters, users, drive details, etc. And this would generally reside on a separate server, but in this case, for demo purposes, it just happens to be on the same server. But what I want to do is move these 5 tables over to the EDW database in the schema, which is SRC, so 1, 2, 3, 4, 5. So I want to move and use the data flow component and move these 5 tables. In order to do that, I've created 5 separate packages. Notice you have 2 additional packages. One is called the run all, and this is built for you automatically. The run all is designed to run every package that you've put in this project. And if you want to take a package out, well, it's all you have to do is select it and move it over, and this is actually is taken out of the project. So if I were to build it now, it would just include these 4. This, by the way, normally you want to filter the packages that are not used in any project. But if you were to unclick that, you can see all of the packages that are a part of this particular environment. So not only the packages that are in this particular project, but all the projects that have been defined. And you can see a list of the projects up here. So we have the host ops, which is to move your raw data from the operational system into the EDW stage source area. And then the EDW refresh, which will create the dimensional model. All right, I'll go ahead and put this one back. I want the data flow for drive details. If we go from right to left and take a look, or sorry, left to right, here are the connections that I mentioned. And we're currently using all the data connections that have been defined within this instance of Biml Snap for this particular tenant. Because we have 3 different databases, if we go to parameters, we'll see the 3 databases and their 3 associated parameters, the database, the provider, and the server. If you want to add a connection, you click on Open Data Connections, and over here we'll just say there's a test connection which is on server 1, and it's using a test database. And then when you click on Save, you can see you now have another connection. If I go back to my connections, you notice it did actually create it as well as placed it inside of the project, because the idea is you could do it in 2 steps, but the chances are when you create a new connection, you want to do it in the context of the current project. But if not, you could just move it out. In the same way, the parameters, you can see we've got 3 test parameters that were created as well. So this, again, for configuring projects through the deployment cycle from dev, test, QA, etc. If you want to create other parameters, then you simply click on the parameter button, and these are defined in an identical fashion to what you would do in Visual Studio. And here you would give it the type and then the initial value of that parameter. Okay, then finally you get to packages. To create a new package, you create on the Create New Package button, and here you tell it which type of package that you want. We have a total of 5 that are available, and you can use these to build almost anything. These, even though there's only 5 patterns, essentially you break everything down to either the pipeline, which would be the top, or the E and the L, or the transformation once it lands on a common server, and you can use an execute SQL to do your transformations. So your merge statements, your partitioning statements are all execute SQL. Your pipeline from operational systems are data flows. So we could look at a sample data flow, and we start with what's called the package qualifier. The reason we call it that is the name itself is derived from a couple of different values within the data flow pattern. You can see what the name is right down here. So the name is a data flow, and that tells you right away when you're looking at this package, it's a pipeline. It's a data flow. The package qualifier says I'm moving from my operational system into my source schema for the EDW. And then we append the actual table name that you're moving over. In this case, it's drive details. And so that tells you quite a lot just simply by looking at the name of the package that it creates. If you want to make a similar package, we have a clone option. It clones everything exactly the same. And then you can go in and say, well, I want maybe a different table. And you can see we do have our the metadata, so it will populate our tables for us. If you choose not to upload your metadata, you can still just type in anything that you need, but you know, the user experience is just not quite the same. Okay. Then finally, what you want to do after you've defined all, one other thing, the sequence package execution. You can sequence it to run in whatever order. If you give it the same number, then it will run these in parallel. So when you have 2 or more packages with the same number, it will automatically create another package for you, which is a group. So package group 0 for this particular project will actually house these 5 packages. If they were all sequential, or for any ones that are in fact sequential, you can go back and forth in the same project, then it would run in that order, invoke a group, run in parallel, and then can go back to running serially. Okay, so to actually build, you come into the build pane, and here's where you choose the template. Now, the nice thing about this is during the development cycle, you probably want to mostly go with no alerts, because you don't want to be sending out alerts when things go wrong to people who it's just spam. However, when you're ready to move to production, when you build, you would choose it to, say, the standard template, and then use it in that fashion. But we'll use no alerts. To actually build, you click Build a Current Project, and you can see that it's populated these two boxes. This is your Biml, and these are all your parameters. So this will correspond to, if I go to Visual Studio, this is actually a different project. Let me open up the host. Oh no, that's the right one, sorry. If you come into the actual project, first of all, the parameters. If you right click on parameters and choose view code, you can see that what the XML looks like to define all of your parameters. From Biml Snap Online, here's all your parameters. So you just copy that over and paste it into this particular window. And now you have all of your project parameters defined. And the same thing with the XML. And so, if you again, you do need to have Biml Express for this. Once you have Biml Express, you're able to add a Biml file to your Visual Studio project, and that would actually be right here. So you can see what the Biml looks like, and that is precisely this code. So you just copy that and paste it. And you can see this is exactly what we had looked at earlier in terms of the Biml that's being written. So here's your connection, the expression, host op, PDW. But of course, we go beyond that to define the project, the connections in the project, the parameters in the project, and then the packages in the project. We always create a run all, and so that's what this looks like. So when you go to run it, everything is in package group 0. So we'll go over to package group 0, and then you'll see the 5 packages. Sorry, it's a small font defined here, and these will all run concurrently. Okay. We also have a second project defined in here. So this is just the data flows, but now we want to actually build the EDW. So this is a separate project. It could be part of the same. You can see the connections that we're using, and we don't actually need host ops in this one, so we can take that out. So this is everything now is in the EDW, so that's all that we need. We've got the Runtime Database. This is going to accumulate the row counts, start time, end times, any errors will be logged, and it will record this in a historical fashion. Just real quickly, this is one of the, when you download, you'll get this framework database, and so this is a DDL for it. And when you run this script, it will create this particular database, SSIS data. And there's just a handful of tables. Whenever you run a project, you'll get a batch log. For each package, you'll get a row in the execution log. during execution. When it finishes, it will move that into execution log history. So the actual packages that you build, if you choose anything but the no framework template, it will populate, and so you want to have a copy of this so you can accumulate row counts and errors, etc. And just to show you quickly what type of information you're collecting, this would show you the row counts, start time, end time. Server execution ID could actually be joined to the SSIS DB catalog if you want to find out more from what SSIS collected. So it is you can join to those tables by using the server execution ID. Okay, so back to Biml Snap. These are your two connections. You have the parameters that are associated with it, plus a couple of extra parameters. This parameter I'm going to use for an incremental load of the fact table. We do use partitioning as an option. And what it will want to know is what date to use in order to repartition or update using switch in, switch out metadata operations on your fact table. And then force run all, this is a way to override the smart rerun ability. If you say, well, no, I want to run everything this time, you can set that to true, which means it won't do the intelligent rerun. It does the brute force rerun all. So and you can add any other parameters that you would like to your packages and then reference that in your code. All right, what are the packages that were built for this? Well, we have some execute SQL statements, and this is going to stage the host table from the source that we just brought over. So we'll take a look at this particular package. We give it a package qualifier. Again, the name is going to start with the package pattern, which is execute SQL, dash, then the package qualifier name. So again, it's not quite a full name of the package, but it will be incorporated into the name. Here's the connection. So on the EDW connection, which you saw how that was defined, it's going to run this particular stored procedure. And that's really all that this is going to do. Very, very straightforward. Let's go back to the other packages. So these are very much the same. Loading dim date. So we do want a date dimension. Now we get into the merges, and this is really where the metadata pays off. So for the very same table I staged, I want to run a merge statement to actually take it from the staging table and merge it into the formal dimension, which is called dhost. So if I go into here, again, I'll see this is an execute SQL. The package qualifier is appended. I'm going to run this on the EDW connection. But notice the actual query is grayed out. Well, it's grayed out because this is code that's generated for you. Because it's code that's generated for you, instead of writing it, you just configure the code generator. And that's what this option is here. You can see that we're using the standard merge configuration table. So if we click on this button, you'll then see here are the here's how you configure your merge statement. Remember, it needs your metadata. So you start by saying this is the metadata database. From that metadata database, there is a table out there using the schema stage under the name host and driven or residing in this database, which is parameter driven. Again, you may run this in another environment where the database name is different, so we drive that via a parameter. That's your source. Okay, now where are you going to merge it into? We're going to merge it into same table name, the EDW database, which happens to be the same. It's a source staging versus DBO. And your destination table is dim host. Well, if we take a peek at these two tables in the EDW schema, we'll see here's our source for dim host. And you can see it has, I don't know, about 20 different columns. What it does not have is the host surrogate key. Instead, it would have this business key called host role. And it also doesn't have the 5 supplemental columns, which are effective date, expiration date, is it current, the insert and update row dates. If you look at what we're merging into, which is DBO dim host, now you can see that it's got a host key. This is the business key that we're going to merge based on where host role is equal, or think server name is the same. And then we're going to append these additional columns. So you might think, well, I didn't really specify that anywhere. Do I need to use these names, or how is that handled? In order to do that, we have an open added column naming form. So you could use the standard, and the standard would use this particular naming scheme. Row is current, row effective date, expiration date. But if you wanted something different, then you can say my naming, and then just give it the specific names, save, and then after you do that, you'll have another option that will appear here. So you can adopt whatever naming standards that you would like for your dimensions. Okay. So that shows you how you use the code generator for merges, and we do a total of 3 different merges. Now we do partitioning, and the partitioning also uses code generators, and we'll go ahead and open this up. Again, this is going to partition or repartition your table, and it is going to be based upon how you configure the partitioning. So if we look at the query configuration for your partitioning table, again, you can't change this. You have to change the configuration of the code generator. What you do is you say, well, here's the name of the schema and the table. This is the partition scheme and partition function. Now, we don't create that for you. It's a fairly simple statement to do. But what this really does is it defines a name of a function, and the scheme applies that to one of your file groups, usually primary. So this just takes a second to do. But what the harder part is, how do you define what your partitions are going to look like, and then how do you maintain those partitions? So I want to have a total of 30-day partitions, and then I want that to be followed by 12 monthly partitions, and finally I would like 10 yearly partitions. So this will give me a little bit over 11 years of data. I go with day partitions because I'm using this to determine the volatile part of my fact table. If I need to update or switch in and out partitions, I'd like to do it just on a day basis, and preferably maybe the most recent couple of days. But it all depends on your fact table and the volatile portion of it. But most places, it's the last couple of days that tend to be the most volatile for transactional-based information. But you can obviously choose whatever partitioning that you would like. So what that will do is repartition the table. And the reason I mentioned repartition is because if I say I want 30 daily partitions and I'm starting today on the 21st, then that's going to go back to roughly February 21st. But tomorrow it's going to be a little bit different. And certainly when I roll over to a month, I've now changed my monthly partition. So you can see these things are always changing. If I give you an example of how this might play out, this will show you the current partitioning for this table. Let me go to EDW. Okay. So you can see that I have 30 daily partitions, and that will run until roughly, looks like the 20th of February. Then I go to monthly, and then I go to yearly. So if I did I run that yet? So if that's the current partitioning. When we run the repartitioning, it looks at today's date, and this is the code that's generated for you. It needs to know the partition scheme and function and the table you're partitioning. It needs to know how to partition it. And then it will look at the current partitioning. It will then adjust that. It will add boundaries if it needs. It'll remove boundaries if it needs. And so after you run this, oops, I got to be in EDW. So now it has repartitioned to bring it up to date with the current partitioning. Okay, so once we do that, once we repartition or partition this fact table, then the next thing we want to do is have a data flow to populate those partitions. And ideally, they're just going to be the last couple of days. So this is a data flow expression. It's an expression because it's a little more complicated. We have a parameter that says from this date forward, we want to extract metadata. And so this is what the select statement looks like. This is standard SSIS expression language. So we're going to select where the insert date is less than or equal to actually I think I probably went greater than or equal to the start date for the performance counters. So this is a data flow to run this. It'll populate on this connection, EDW, this schema, destination table. Here's the package name. So that will populate, and these are standard inserts. You can see this is a select statement, which will be a data flow into this particular table. So that will be a standard data flow, but now what we want to do is switch that in. What does that look like? Okay, here's our performance counter table. We have a performance counter in. That's what we just populated. We're going to switch all of those into this fact table, but first we have to take that same partition and switch it out. So you do have to write these or create the DDLs for your fact tables. They're defined in an identical fashion, but you need a switch out and a switch in order to accomplish the metadata, and they all have to be in the same file group. All right, so finally that gets to this last package, which is SwitchIn. It's an execute SQL expression again. You can see it's a code generator. We'll define the code generator or that will configure it. What we need to know is what is our SwitchIn table. So I put it in the part schema, and I have a suffix of in. This is what we populate with the data flow. Now it needs to know what are you going to switch it into. I'm going to switch it into the DBO performance counters. And what the switch out, or the partitions that are no longer desired, will go to the partition schema partition out. And the only other thing it needs to know is based on what date. So based on this date that we give it, which is, by the way, the same date we use to populate the SwitchIn table, we pass that very same parameter to the switch in and out program. And so we know that the same logic applied when we populated the fact table as when we're switching in the updated partitions. Okay, so we have fully defined our dimensions, the staging, the merge, partitioning. Now we can go over to Visual Studio, and we'll take a look at that particular package. We only have a couple of minutes left, so I'm going to have to try to wrap this up pretty quickly. But this is the packages. Just to show you the power of Biml, because we only have a couple of seconds left. If I were to say, and a lot of people gasp at this stage, I'm going to delete all these packages. I'm going to delete these connections. Now I go to Biml script, and you saw this just a minute ago. I'm going to right click and choose generate. And with any kind of luck, it's going to rebuild all the packages, create all the connections, give us the run all. So here's our run all. This is what you would schedule in SQL Agent or run from the catalog. And you can see all the packages. These are running serially, so we do first the staging, merging, and then finally the fact table. So I'll go ahead and click on start. And so now it's going to run through each of these packages. If we look at the SSIS data database, the execution log, you can see where this is now being populated. So far we've run through most everything. If you run through it again, looks like we must be on the last project. Oops, find the right screen. Run all. Okay, we're done. And you can see these have been cleared out. The reason the project ran successfully, the rows were moved into execution log history. Here you can do your metrics on the over time or trending of row counts and run times. And then to summarize, there's the batch log. And so the batch log will tell you, based on what just ran, batch 15, 10 packages ran and moved 160,000 rows. All right, well that's it in a nutshell. I know I kind of didn't take a breath through all of that. I assume you have questions, and Jason had recommended that he can coordinate any questions that you have, and we can have a dialogue offline. If you need any help getting started, please email us. If I go back to, and we can send you this deck, but just at the last minute, this is how it all works. This is kind of the money slide. When you define these packages through pattern, or in configurations, it pulls the pattern, it pulls the framework into the template. A stored procedure builds all your packages. Another stored procedure runs, pulls in your connection, pulls in your parameters, creates your project XML. You move that into Visual Studio, build, and you're done. So that's behind the scenes how it all works. A little more in the code generators. Finally, the links. If you want to copy this presentation, you can email me at info@bitracks, or you can ask Jason, and again, I'll be happy to follow up with him on whatever questions you have, or if you need help with downloads, installing, or again, you need a copy of this presentation. So with that, Jason, I think I can turn it back over to you.
Alrighty, thank you so much, Jim. We got a couple quick questions I can run through.
Okay.
See if I can answer them pretty quickly. One is, what's the advantage of using Biml Snap to create pure Biml from SQL scripts over creating my own solutions using Biml script?
Well, yeah, and so that's it is a perfectly viable option to use what you see, if you can still see my screen on the right side. It does take a little bit more knowledge to do this. For example, you really need to understand the tags for Biml. Now, we use Biml tags, but there's nothing within our solution that says you have to understand the hierarchies, the properties, or the attributes and tagging scheme for things, such as packages and connections and projects and variables and parameters, et cetera, et cetera. The other thing is you have to also have an understanding of C# as well as the object model that you're querying. So if you happen to have all of that at your disposal, a good understanding of the Biml tagging structure, a good understanding of C#, a good understanding of the object model that you would be using in C#, then there really isn't much different. Although what I would say is that if you wanted to have a very standardized development process where when you're done, you turn this over to somebody who doesn't need to go through a lot of code, you might end up with a little bit more understandable end product. But yeah, they do the same thing. It is a very similar approach. One is table driven, form driven with our front end. The other is really all code driven through C# object models and Biml.
Alrighty, last question since we're running over. What information do you store on the Biml Snap server, and how are you GDPR compliant?
I don't know if we are GDPR compliant. We do use SSL. We do separate everything by tenant. I don't think we're getting anything that is sensitive. Now, if you do in fact say, well, my table names, my column names, my column types are sensitive, well, that's fine. I understand if you want to do that. You could still use it without the drop downs, but I think it does lessen the overall impact of bimlsnap.com. But you can still use it if you want to just do a handful of data flows. Create the Biml for that, and not store any of your metadata. That's perfectly fine, because the metadata really comes important on the build. You're building in Visual Studio. This is when it actually needs to formally hit your metadata. So you don't really have to upload it, but I think you'll find it's easier to use. Finally, if there is something in there that would be more sensitive, maybe a database name. You don't want to leak out a database name. You could always put in an alias. It's one of the reasons with the host I put in a host role or host alias, because a lot of people don't want to let that information out. What you could do though is after you build, then you would simply, and we'll go back to the build and build this current project. You could copy this and then substitute just any simple text editor to change the name of what was sensitive, what you didn't want in there, to what was, to put something not sensitive in Biml Snap, and then once you download it, do a quick search replace and fix it so the sensitive information would never leave your on-premise computer. So that would be another option. Alrighty.
Well, thank you, Jim, for presenting.
Certainly.
And thank you everyone for attending. Once I wrap everything up, I'll have this session uploaded to our YouTube channel as well. And I guess, Jim, the slides will be available. I guess, what was
Yeah.
the link?
Yeah, if you just send to info at bitracks.com, if you send me an email, I'll be happy to send this presentation out.
All righty. Well, if anyone has any further questions, they can send us an email, and I'll try to answer them accordingly.
Okay.
All right. Well,
All
thank
right.
you.
Very, very welcome. Thank you.
Bye.
All right, bye.